Well, good afternoon. My name is Shane Falkwell. Retired from the U.S. Air Force. I served 22 years and I worked on ground support equipment for my whole career. I retired in 2015 to start working for Hydraulics International. I conduct after-sales support, troubleshooting, training, and I'll be your primary point of contact if you have any questions or issues with our equipment. So feel free to email me with any symptoms, problems, concerns, questions, anything you might have. So this is the UHTS 101197-100 two-system hydraulic test stand. To turn this on, we're going to open up the engine access door. And we're going to turn the battery switch from off to on. Now we'll open up the control panel. And to turn power on, rotate switch 1 from off to on. Make sure your emergency push button is pulled out. Turn on your panelized switch so you know you have power. It's about 45 seconds for the HMI to fully boot up. It's time, if you want to check your battery voltage, turn your engine start switch from off to run and wait for the engine display to fully boot up. Here you can see RPMs, engine temperature, oil pressure, the battery voltage. You press the down arrow, it'll take you to RPMs again, engine coolant, manifold temperature, and your engine load percentage is displayed here during operation. Now that our HMI is fully booted up, we're going to press the push to continue button to proceed to the home screen. Okay, you're on the home screen. You have system 1 information. You have supply pressure, flow in gallons per minute, return back pressure, boost pressure, oil temperature. You can operate your fill pump by pressing this button. And over here you have aircraft and test stand. We're currently set to test stand. Anytime you're operating the unit and you're not connected to an aircraft, please ensure that these are set to test stand. Now system 2 is identical to system 1. We can come down here. We have reservoir level, purification moisture content, engine fuel level, inverter on indication. When the engine is running and the inverter is on, there should be a green light right above it. Once that green light turns on, after about 15 seconds, your purification system light should start blinking green. These indicators here show you the level inside of your purification tank. During normal operation, you'll have level 1 and level 2 illuminated. Down here you can see fault information. If you want to access the fault log, press the info log button. It'll take you to another screen. And here you can see past faults. Now if you select a fault and then press the info button, it will give you more information on what caused the fault or potentially how to resolve the fault. Also on this screen, during operation, you can see which valves are open and closed, such as system 1 bypass, back pressure bypass valve, solenoid 1. If it's energized, green, it'll be closed. And if any of these other lights are green, that means it is energized. Down here again, we have the purification level. And if you need to drain the tank, you can press drain tank on and it'll automatically drain the level until it reaches level 1. Once it reaches level 1, it'll stop draining. From that point, if you need to take more fluid out of the unit, manually discharge by pressing this button and holding it until this light goes off. At any time, if the horn sounds, you can press this button to make it stop, and if it is not sounding, you can press this button to test it. Over here under purification system mode, we're set to normal. Under normal, when you start the engine, purification system will automatically turn on. If you select service, you can turn on the unit and operate it, and your purification system will not turn on until you've returned to the home screen and you manually turn on or off the purification system. Over here you can see your engine hour meter. Right below that is another acknowledge and test horn. And right above that is purification mode. Its default setting is UHTS reservoir. If you want to select an alternate setting, press the drop down. You can select external reservoir, system 1 aircraft, or system 2 aircraft. I can get into those later. As you saw earlier, the reservoir level on the HMI was indicating negative because that unit had been drained and ready for shipment. This unit is fully serviced, and I'm going to walk you through how to service the reservoir so that you can operate the unit. So before we begin, let me give you a little bit of information about this reservoir. It's an 80-gallon size reservoir with about 67 usable gallons inside of it. Also located inside of this is a bladder. The bladder inflates and deflates, and it displaces the fluid level. So if it's down here, the bladder inflates, it's going to push the fluid level up. This can often lead to incorrect level settings on your reservoir, so you need to be sure that you follow the procedures in the tech manual properly. To begin, you want to go ahead and remove your two-way 5 psi relief valve. You can press this in and relieve pressure, but it's easiest just to go ahead and remove this. The best tool for this job is a Ford wrench. Once you've got the two-way relief valve removed, come around to the back, and up in this corner you're going to go ahead and open the reservoir drain valve. That's going to allow air to enter in through this port and start filling the reservoir with air. Now you'll come back over to the HMI side of the unit, have a ladder set up so you can reach the top. When you initially receive your unit and it doesn't have any fluid in it, you're going to find these 4 bolts on the inside, 2 on this side and 2 on the other, are going to be fully run down. What that does is it brings the reservoir up for transportation. Once you have all 4 of the inner nuts fully backed off to the cotter pin, you'll be ready to fill the reservoir. Now you want to go ahead and fill the reservoir prior to adjusting your leveling nuts. Now, I talked earlier about relieving the air pressure from the bladder. It's imperative that you do this, because if you don't, you're going to get your reservoir levels incorrect. With the two-way relief valve removed on the other side, go ahead and remove your dipstick and start servicing it with the correct fluid for your aircraft. That may be 83282, 5606, 87257, or in some foreign countries they use Aeroshell 31, Aeroshell 41, etc. It's important that you use what goes in your aircraft. You can see here on the dipstick you've got 3 levels to work with: 47 gallons, 55 gallons, and 63 gallons. My suggestion, go ahead and get it 55 gallons. Now that you've serviced your reservoir, go ahead and insert the dipstick and screw it all the way down. Once it stops, go ahead and unscrew it. pull it out and double check your fluid level. We're at approximately 56 gallons. We've got the reservoir fully serviced, so what we'll do is go ahead and reinsert the 2A relief valve. This reservoir only has about 5 psi in it at any given time. It has a 15 psi relief valve just in case of emergency or overpressurization. So with that in mind, this bladder on here has an O-ring which keeps the air inside. So when you install this, just install it and give it a good twist with the hand, so nice and hand tight. Do the same thing with your dipstick for filling. This prevents you from having to break out wrenches later on when you want to check the service level of your reservoir. Come back to the back side of the unit and go ahead and close this valve. Remove this panel here so you have access to the top of the reservoir. The 3/4 inch wrench will fit right up on here. Somebody can stand here and hold this while you ratchet from the top. Now from the top, with somebody holding a wrench on the inside, place your ratchet on the outside nuts, and you only need to adjust the 2 nuts on this side, so this one and this one. A slight turn clockwise will decrease the reservoir level on the HMI, and turning it counterclockwise will increase the reservoir level on the HMI. Now when you're ready to adjust the nut on the right, you're going to have to go ahead and reach inside with the wrench like so and position it on the bolt head. Alright, so I have that positioned, and then on the outside I can turn with my other hand and get the ratchet to go send the nut up or down. When you're ready to start using the unit, there's a couple things you want to go ahead and walk through and verify the levels of. First of all, we'll start with the battery. Make sure your voltage is well over 24 volts. The unit can start down to 20 volts. It's possible that the HMI could kick off, but it should reboot as soon as the engine's running on alternator power. To the right of the control panel, inside the engine access door, you'll find the coolant level sight gauge here on the expansion tank. If you find your expansion tank requires additional coolant, 50-50 coolant mix, you can open the top access panel, go and remove the cap, and service it as required. Here we're on the left side of the unit. We don't have any panels on here, so you would actually have to open this access panel door and then either open the small access panel for the engine or remove this whole panel altogether. So in here you can check your engine oil. Make sure it's at the proper operating level. You're also going to remove this cap to service the fuel tanks with diesel. Once you have the tanks full and you're ready to run, we need to prime the fuel filter. Alright, fuel tank caps reinstalled. You'll see just to the right of it is the primary fuel filter. Prior to running it for the first time, you want to go ahead and open the pump and start pushing the handle. Now it's going to be real easy when you have no fuel in it, but you're going to push this until it gets tight. Once you get tight, you should have enough fuel in your lines to start the engine. Just around the corner from the fuel filter, you'll find the gear case dipstick right here. Grab a wrench, pull it out, check the dipstick for the proper level of oil. With everything serviced, before we start the engine, again, we want to come through and make sure that this valve is open, the drain valve is closed, purification system return is open, and the purification supply is also open. I'm going to cover pre-operational setup, so which position do you need to put which valves in, and first thing I want to look at is this placard here. If you're ever not sure how to operate the unit, you can follow this placard step by step and it'll carry you through the whole process. So upon coming to the unit for operation, you want to make sure that your pressure control knob here is fully counterclockwise. Your back pressure control is fully counterclockwise. Your bypass valve is also fully counterclockwise. And your supply shutoff valve is fully clockwise. Now you'd set this up the same on both systems. Now I want to talk about your bypass valve and your supply shutoff valve real quick. At the end of the shaft is a needle point. That needle point could be damaged if you turn these in too hard. So once you've closed these, just give them a little tug. They do not have to be jam tight. If you jam them tight, you will damage them. So for point of reference, the needle on the right is in perfect condition. If you jam your supply shutoff valve or bypass valve closed too hard too many times, you will deform it and it will not seal properly. Next, we're going to look at the volume control handle. Its position determines the amount of flow that'll be indicated on your GPMs. Its initial starting position is not very important. It's once you have the unit operating. You want to be able to rotate this clockwise to decrease GPMs or counterclockwise to increase GPMs. When this is fully counterclockwise, you should be between 55 to 58 gallons per minute. This nut is important. It should remain in place. It should never be adjusted. If you have to adjust this, then you need to more than likely recharge your volume control system, which I'll cover later. So as you rotate this fully clockwise and you bring this nut to stop, your gallons per minute should be around 3 to 5 gallons per minute. So here we see the vent valve and the vent tube. When you depress this vent valve, boost pressure from the system is going to push air from the top of the low pressure filters out through the tube to the bottom of this valve. You depress this and that pressure pushes any air out through the tube, which then goes back to the reservoir. This system works exactly the same for system 1. Down here we have the verification box. Upon initial receipt, you want to open this box and make sure that each of these valves is fully counterclockwise. Make sure each of these caps is properly secured. They don't have to be too tight, just secured. Here we have the IVS verification port. So if you're operating an IVS, you plug this in, it will activate this button right here for instrument verification. Over here you have your 115 volt power outlets and a circuit breaker switch to turn it on and off. If it draws too much amperage, the circuit breaker will automatically trip the switch to the off position. And during operation, when the power is on, you should see a green light here in this little block. Now the purpose for ensuring that each of these is fully counterclockwise is behind this panel is the pressure transducers. So here you have supply pressure, boost, return pressure, and boost pressure. If this is closed, your pressure transducer will not receive the pressure that it needs in order to indicate. You can encounter various false positive faults. When you're switching between test stand and aircraft, you'll hear the motor turn on the selector valve. There's also an arrow on the selector valve that points to the position that the selector valve is in. So currently we're set to test stand, which you see here, the arrow's pointing to test stand. You want to switch to aircraft, press aircraft and you hear the motor. The motor is finished. And now your arrow is pointing to aircraft. Now there's a very important safety aspect that I need you to remember. This unit can be started. In other words, you can start the engine while the selector valve is changing positions. If you do this, you will blow out the side of the selector valve and lose all the hydraulic fluid in your reservoir. So be absolutely sure when you're changing it that you do not start the engine. I'll go into a little bit more detail on the selector valve rupture. So during movement, if you start the engine, the pumps will start rotating and moving hydraulic fluid. As soon as this selector valve hits a position where the fluid can no longer flow, you're going to build pressure through these lines in the selector valve. That pressure is going to exceed several thousand psi. And these 4 screws will strip right out. This will pop out and you'll lose all your hydraulic fluid out through here. Now on both the UHTS diesel, if you open up this panel door here, you'll find the fill and purification transfer pump shutoff valve here. This should always be open. On the diesel, the fill pump is right down here. So make sure this valve is open. And then on the rear of the unit here, we'll find 4 more valves. You have the supply valve for the cooling pump and the purification system. This should remain open at all times. I would highly suggest you safety wire it open so it cannot be inadvertently closed. On the diesel, you have 3 more valves. This is your reservoir drain. When you open this, you can drain your reservoir through this port right here. This should remain closed at all times. And then you have 2 more valves here. This is your purification supply shutoff valve, closed, open, and your purification return valve, currently closed, should be open. If at any time on the diesel you're operating the engine, if you close this valve, you will cavitate and destroy the cooling system pump. The cooling system pump can be located on the front left access panel door. Open that and then open your engine access panel. And this here is your engine cooling pump. It's driven by the motor, so anytime the motor's operating, that pump is moving. It must have hydraulic fluid flow to it at all times. I'm going to discuss purification system operation. So the valve on the far side should be open, and you'll feed along this black tube hose right here, along this line down to moisture separator filter 1. Alright, this is a spin-on filter which removes moisture from the fluid. This switch here is a negative pressure switch. So if it draws on a vacuum about 10 inches of mercury, that switch should close and provide an alarm telling you that you've got moisture separator filter 1 clogged. After the moisture separator filter, it goes to the charge pump. The charge pump then pushes that fluid up the lines to the charge filter. From the charge filter, just 3 micron, it runs up into the top of the purification tank into nozzles. There's 5 of these nozzles all the way around the tank. The nozzles atomize the fluid inside the tank, turns it into a mist, and then that mist meets a welded in screen which turns it back into droplets. Those droplets fall to the bottom of the tank where the discharge pump draws that fluid out and sends it through the discharge return filter, which is also a 3 micron filter. From this filter, fluid then gets pushed over to water separator filter number 2, which also has a differential pressure switch. And after here, it passes through moisture sensor and then up to the reservoir. One of the common mistakes found is the UHTS will signal that the moisture separator filter 1 is clogged. You replace the filter, it'll still be clogged. Replace the filter again, still shows clogged. The most likely reason for this is due to insufficient hydraulic fluid level in the reservoir. So if you don't have enough fluid in this reservoir, on your supply line going to your cooling pump, remember the black line here? That cooling pump is going to draw more fluid than is available. As it draws that fluid, it creates a suction that's fighting the charge pump, located here, creating a suction which triggers this switch. So the first thing I recommend is, if you do get a moisture separator filter 1 fault, that you verify that you have the proper hydraulic fluid level in the reservoir. Back to purification system. Once the charge pump is operating, about 10 seconds later, discharge pump will start operating, and then the vacuum pump located here. So once the vacuum pump turns on, it'll start drawing the air, dissolved particulates, gases, and moisture along this line here through the pump. The pump's going to draw the tank into a negative 25 inches of mercury, which you can see on this gauge. Now this gauge is connected to the desiccant filter. What this does is there's a spring-loaded relief switch right here, which prevents the tank from being drawn into too heavy of a vacuum. And anytime this spring opens to allow air in and maintain the vacuum, the ambient air passes through these silicon beads, which draws the moisture out of those beads, so you have dry air going into the tank to maintain your vacuum. Another item to address is when the vacuum pump turns on, this solenoid will close. This is an air inlet or exhaust for when the vacuum pump shuts off. This allows air to come in and depressurize or release the vacuum in the tank. Vacuum pump turns on, this closes. Vacuum pump turns off, this should open. As the vacuum pump is drawing out the air, it's also going to draw out hydraulic mist. So the hydraulic mist will run along this tube over to this glass jar. This glass jar will fill up over a matter of time. So be sure to clean this jar out. You don't have to wipe it out, just drain it prior to operation, or anytime the fluid gets up to the bottom of the muffler inside. Very important item to note on this glass jar, do not over tighten it. When the vacuum pump turns on, it's going to draw this jar into a vacuum also and create a better seal on the gasket that it's sitting on. So unscrew it, drain it, reinstall it, and when you feel it hit the gasket, give it a twist. Do not over tighten it. This glass jar will break over time or too much pressure. If it breaks in your hand, it could be dangerous. On the outlet side of the vacuum pump, you'll find this other glass jar here. This glass jar is to catch the oils and vapors that are coming past or through the vacuum pump, and they collect in that jar there. That jar will not fill up very fast at all and should be cleaned out periodically. After this glass jar, it comes over to your odor filter right here. When you purify hydraulic fluid, it creates a very nasty smell. So inside of here is a filter that will clear the smell and not create a stench coming from your unit during purification. Inside of the purification tank is a level switch. It has 4 floats on it. So each float does something a little bit different. When level number 1 is not illuminated, your charge pump will turn on and start filling the tank. Once it reaches level 2, your discharge pump will turn on and your vacuum pump will follow the discharge pump. Now if the level proceeds up to level 3, you have a solenoid up here that energizes and opens a bypass. So the pressure from the charge pump will start recirculating back to the charge pump through the filter. Fluid will continue to fill into the tank, just not at such a high rate of speed. Now once you reach level 4, it triggers an alarm. Your charge pump, your discharge pump, and your vacuum pump all shut off. At which point you'll need to go into your info log screen and manually discharge the tank. Okay, we're ready to start the unit. Go ahead and turn on the engine. Let this boot up. Rotate the switch to start. Now you want to give it about 3 to 5 minutes for the engine to warm up, or until the temperature gets over 100. Alright, with the engine idling, you see the inverter is on and the purification system is operating. Now that the engine's warmed up, we'll use the increase switch to bring the engine speed up to 2100 RPMs. Now that the engine is up to speed, we want to vent the systems to ensure that all the air is out. So press the button several times and watch for air. If you still have air in the system, continue to vent. Repeat it on system 2. Again, if you have air in the system, vent. Here you can see the volume is set to maximum, so we're going to decrease that by turning the volume control clockwise. Now we'll adjust system 2 by again turning the volume control clockwise. You can see here we've got good boost pressure. You want to pay attention if the boost pressure drops below 15 psi. you'll get an alarm and the unit will automatically shut down. Now, as we close the bypass valve, you'll start to see the boost pressure increase, but you'll also see supply pressure increase, which is the standby pressure for the main pump. We'll go ahead and close both System 1 and System 2 bypass valves. You'll notice the same increase on both systems. The pressures may not be exact, but those are good pressures. I mentioned standby pressure on the main pumps. Without standby pressure, you will not be able to build pressure on the systems. Now we're ready to build pressure on System 1. So we'll go ahead and close the pressure control knob clockwise, and you'll start to see an increase on supply pressure. Now, the pressure control knob requires minor adjustments to increase pressure at decent rates. All right, we have System 1 set to 3000. Now let's set System 2. Again, pressure control, clockwise, increase supply pressure. All right, now that we've set our pressure and we've set our flow, we're ready to apply pressure to the aircraft. So first, we'll go ahead and open the bypass valve. System 1, System 2, doesn't matter. Now you see the pressure has dropped and the flow has increased. This is due to the flow circulating within inside the unit. Now, once you've finished operation on the aircraft, you go ahead and shut down the unit. We're going to open the bypass valve first, and then we'll close the supply shutoff valve. Repeat, System 2, open the bypass, and close the supply shutoff. At this point, there's no load on the engine. You can decrease the speed to idle, and then give it a few minutes for it to cool down. So I discussed earlier about the volume control recharge procedure. If you find that adjusting your volume control, you can't get your gallons per minute down to the lower range, let's say below 20 gallons per minute or lower, go ahead and back this all the way out. This goes for both systems. Once you have the volume control all the way out, you come around to the back side of the unit, and you'll open System 1 or System 2 bleed valve. What this does is it allows boost pressure to enter into the volume control system. Now, back on the front of the unit, with those two valves still open, you're going to go ahead and close your bypass valves. And this is going to give you anywhere from 60 to 90 psi on your boost system. Once those are closed and you have 60 to 90 psi, go ahead and close the two valves on the boost pumps. Clockwise and clockwise to close. Reopen your bypass valves. And now you should have full control of your volume control from maximum all the way down to minimum of around 5 gallons per minute. Now, just some FYI. the HMI does have a dimmer switch on it. So if you're not careful, you could make it look like it's off. Dimmer slider is down here at the bottom. Touch anywhere on the bottom of the screen. Make your screen dark, make your screen lighter. Now that we have the unit shut down, we can go ahead and turn everything off. Start with switch 1. Turn that off. Engine is already off. If not, set this to the off position, not accessory. Off. Push in your emergency stop. And then turn your battery circuit off.